In this video, we are going to discuss something called the normal distribution. So, the normal distribution I have shown here, this normal, what's called a normal curve. And this begins with what we call um, the, we call this the 68, 95, 99.7 rule. And what this says is that 68% of the data are within one standard deviation of the mean. 95% of the data are within two standard deviations of the mean. And 99.7% of the data are within three standard deviations of the mean. Okay? So, don't worry about these little decimals here. We're going to forget about those. So what we're saying, and let me go ahead and just kind of point out some things. This kind of weird looking U, this is the Greek letter mu, which means mean. Okay? And then this kind of looks like an O with a little tail on it. Okay? This means sigma, and it means standard deviation. Okay? So the 68, 95, 99.7 rule tells us that in this area here, okay, this area here represents 68% of your data. And if we add in these pieces here and here, now you have a total of 95% of your data. And if we finally include these tails out here, okay, now you have 99.7% of your data. Now, something that is really important to keep in mind is that when your data is normally distributed, okay, from the mean this way, this is 50% of your data. And on this side is 50% of your data, because you have to keep in mind, we've got these little ends over here which are known as outliers. Okay? And these outliers are part of your data, but we just don't include them in the 68, 95, 99.7 rule. But you will see a little bit later on that this is going to become extremely important to know that 50% of your data is below the mean, and 50% of your data is above the mean. Okay, so now we're going to take a look at an example of this. So let's assume that we have a normal distribution. Okay. We have a normal distribution. And we are told that we have a mean of 10 and a standard deviation of 2. Okay. So what this means then, we have our mean here, right in the middle, right? And this is 10. And this is our mean. Okay. And so a couple of things that we can tell right off the bat. 50% of our data is less than 10. And 50% of our data is greater than 10. Because remember, that's what the mean is. It is the midpoint. When we average out our data, this ends up being the middle number. And in a normally distributed data set, which is what we are told that we have, the mean, the median, and the mode are all three the same. So even the median of the data set is 10. So that means that half of your data is less than 10, half of your data is greater than 10. Just is the way it is. Okay. Now, it's really important that we know that our standard deviation is 2, because that means that this is our mean minus 1 standard deviation. Or in other words, 10 minus 2, which is 8. Okay? And then over here, we have mean plus 1 standard deviation, which is 10 plus 2, which is 12. Okay? So something that we can tell right now is right here. 68% of our data fall between these two purple dashed lines, which also means that this section here is going to be 34%, and this section here is going to be 34%. Okay? Now, then we have this here. on either side. And this is going to be mean minus 2 standard deviations. So if mean minus 1 standard deviation was 10 minus 2, mean minus 2 standard deviations is going to be 10 minus 4, or 6. Okay. And this over here is going to be mean plus 2 standard deviations, or 10 plus 4, which is going to be 14. Okay. And this green section, remember, this is going to be 95% of the data. Okay. So when we kind of break that down into, like, what does that really mean for for percentages, because this is going to be kind of important when we get into that. Well, half of 95 is 47 and a half. Okay. And since this is 34%, then this ends up being 13.5% in here. Okay. Because if you add up those 4%, you're going to get 95%. All right. Now, finally, right, we have our mean minus 3 standard deviations and our mean plus 3 standard deviations, which is going to equate to, this is going to be a value of 4, and this is going to be 16. Okay. And this is going to kind of run off of the page here, so I'm going to do the best I can here. And remember that this is going to be 99.7% of your data inside of that blue area. So this, I will leave you to do the math. Okay. Because when you take 99.7, cut it in half, and then take out your 13.5 and your 34, that leaves you with the 2.35 for that little percent right there. So now we want to look at asking some questions. So how about this? So what percent of the data are between 8 and 10? Okay. Well, we've already worked this out when we built our normal distribution. So we can confidently say that 34% of our data are between 8 and 10. How about what percent are below 12? Okay. Now, some people will come along and they'll say, well, I'm just going to add up all of those percentages. But I want you to remember something. I want you to remember this. What did we say at first? 50% of our data is less than 10. Okay? So we already know that we have 50% of our data less than 10. So 50% is less than 10. Okay. And then we know that we have 34% between 10 and 12. Therefore, 84% of our data are less than 12. Okay. So let's pause here and come back with looking at some z-scores. Okay, so the z-score table can help us out with some things. So here is our standard normal distribution curve. We have our different percentages. This one even has those little 0.15% tails included, those outliers that we talked about. And this is really, really helpful for when we want to find things, because this is -1 standard deviation, this is +1 standard deviation, we have +2 standard deviations, +3 standard deviations. Down here we have the -2 standard deviations. We have the -3 standard deviations. But what if we wanted to find something that is, let's say, uh, 0.5 standard deviations above the mean? Well, we really don't have anything for that as far as our normal distribution goes. However, we do have that with what's called the z-table. And when we have the z-table here, and let's say that we do want to find something that we want to find the area, okay, because we're looking for the area, that is half of a standard deviation above the mean. Well, what we want to do then, okay, is find the intersection of 0.50. Okay. And when we do that, we find this right here. Okay. And we find that that area is 19.15%. That is what's in between the mean and half of a standard deviation. Okay. So let's say that we wanted to find, let's find the percent of data that is between 0 and 1.52 above the mean. Okay. Well, let me erase that. Okay. So first of all, 0, well, that's right there, right? Okay. But now we need to find 1.52. So we come down here and we find 1.5. Okay. And then we have to put that 2 on the end of it. And we want to find the intersection of these two areas. And we find this right here, which is 0.4357 or 43.57%. Okay. Let's find, how about this? Let's go between 1.52 and 2.63. Okay. Well, we already know that 1.52 is the 0.4357. Oops, did not write that correctly. 0.4357. Okay. So now let's see if we can find 2.63. Okay. So first of all, we're going to take a look here and we're going to find 2.6. Okay. And then we need that 3 on the end. And we're going to see, where do these two things meet? Okay. And we can see that they meet right here. Let's pick a different color. They meet right here at 0.4957. Now, can you guess what we're going to do to figure this out? Well, if we want to see what is between these two, it might be a good idea to subtract. Okay. And you get 0.06 or 6% of our data fall between 1.52 standard deviations above the mean and 2.63 standard deviations above the mean. Now, one more thing that we can look at, okay? And we're going to use what we've done here, okay? Let's say that some data set that we're looking at, okay, this has, we're going to say that it has 200 data values. Okay, so let's say that we're looking at 200 heart rates or 200, engine measurements. And we want to find how many, okay, so how many of those 200 data values fall between the 1.52 and 2.63 standard deviations above the mean. Okay. Well, step number 1 to this is to find out the percentage that fall between those two things, which we've already done. We've already determined that 6% of our data fall between the 1.52 and 2.63 standard deviations above the mean. So if we know that we have 200 data values, then we're going to take our 200 and multiply it by the 6%. Okay. And when you throw this in your calculator, you will get that 12 data values. Fall between 1.52 and 2.63 standard deviations above the mean. As always, I hope that this video has been helpful. Please reach out with any questions. We will do all we can to help.